Okay, so we are at the I hope second last or last video. We are at the PHS Pure Physics 2021 paper. So this is the either question at the end, and it is your typical DC motor, and you can see that actually I think PHS had the prelim earlier, so this question is relatively straightforward, I would say. So in part A, they actually ask you to explain the direction of the coil's rotation. So unlike in what you call that, O level, sometimes O level would ask you, can you please explain why is there a force? So if the question asks you why is there a force, then you need to explain using the interaction of the magnetic field between the poles and the magnetic field generated by the current in the coil. Sometimes they may also ask you why is there a moment. So in that case, you need to explain first why is there a force, and then after that quote the formula M equals to F times D, and then you explain why is there a moment. But for this particular question, they are asking you the direction of the coil's rotation. So because it involves direction, the only way to explain it is through Fleming's left-hand rule. So using the Fleming's left-hand rule, you need to describe how do you apply it. And to describe how you're applying it, you need to be able to tell me that the M field line is from where to where. And then, of course, you also need to tell me how the current are flowing, right? So to tell how the current are flowing, make use of the A, B, C, D labels in the diagram. So, of course, you can say inward, outward, things like that. But it will be much easier if you use the labels in the diagram. Some of you may ask me, teacher, what if there is no label? You can label the diagram. Okay, label it clearly. So using Fleming's left-hand rule and by describing how the magnetic field line are in which direction, the current are in which direction, you then can conclude that the force acting on AB, like I said, you need to be very precise. So in this case, you can say AB, right? Acting on AB. So when you are talking about force, you will always use the word acting on something. So of course, this is not the end. Downward force on AB, and of course an upward force on CD. And because you have to explain rotation, that means you need to relate this with moment definitely. So after you talk about the direction of the force, remember to end your explanation using moment because it is a rotation that you are explaining. Okay, then when you are talking about moment, please tell me direction of the moment about which pivot. So in my previous video, I also mentioned that whenever you mention moment, you must tell me this moment is caused by what. But in this case, I think it is pretty obvious that this moment is caused by the downward force on AB and the upward force on CD. So I don't think you need to repeat it. Anyway, you only have 4 answer lines. So do not overcommit as well. So for part B, this is the answer. You need to take note. You should be drawing the start of the force at the middle, and you should vertically draw down, and then middle vertically draw up. And if you can, make sure that these two lengths should be the same. Okay. For part C, you are supposed to explain the function of the split ring commutator. So always state the first level explanation first, that it will reverse not just the current but the direction. Then on the second line, because it's 1 mark 2 lines, right, explain so what if you reverse the direction of the current, what is the effect of this change. So then explain that it will then reverse the direction of the force, right? Of course, whenever you talk about reversal, you also must mention like when does it reverse. Then there are some of you that come up with very complex way of describing. Actually don't need lah. You can even say that it will reverse it every time it go past the vertical plane, right? So in my case, I choose to describe the moment when it change over by degrees. So I will just say that it will change the direction of the current whenever the coil rotate 180 degrees, right? Remember, you see, rotate every 180 degrees. That's all I say. You don't like this, you don't like degrees, just say whenever it passes over the vertical plane. It is fine as well, okay? Try to simplify your description. You need to state the position where the moment is maximum. So because moment consists of F and D, you need to talk about both of them, okay, not just the D. So in many cases, we say that the F is actually constant, but since there are 4 lines and 2 marks, I will assume that F is also not constant, because as you know, when you have 2 magnets like that, the strongest magnetic field is actually in the center, and as it goes to the side, the magnetic field actually bends, and because of that, it will get weaker. So as the coil start rotating in the center, it will experience the strongest force, but as it rotates to the new position, then it will actually experience a weaker magnetic field at the side. So I will just, since there are 4 lines, I will just say that at horizontal, F will be largest, and as it goes to the vertical, it will be weaker. Then of course the perpendicular D will also change. So this is how I describe it. When the coil is horizontal, the moment is maximum. So I answer the question first because I'm very sure. Then after that, I will make sure that I talk about F over here, and then I will talk about D over here. So when you talk about D, when you talk and speak, right, you can say perpendicular distance. But when you write the answer, you cannot do that. Okay? So when you write the answer, you must give me the full form. Perpendicular distance between the line of action of F and the pivot. This is the full name of perpendicular distance. You need to be able to memorize this. And of course, it is maximum when it is horizontal. And like I said, the induced force horizontal, there is the greatest interaction in the middle. So I will explain it by interaction. Why is it that I will explain using interaction? Because this induced force is caused by the interaction of 2 magnetic fields, right? So if I say the force gets larger, then obviously the interaction must then be larger. So I'm just using that. Some of you may be asking me, teacher, can I say that F is larger because the magnetic field from the magnets are the strongest in the center and weaker, and it will go and it will become weaker to the side? Can. You can say that. You can say that the M field of between the magnet, you know, is strongest in the center, and then as it goes to the side, the magnetic field gets weaker. It's okay because it's just 2 marks. So this is what we call secondary explanation. So the secondary explanation, just give a rough one will do, because it's 4 lines for 2 points. Can? Okay, for part E, you have the same energy supply. You need to come with 2 ways to increase the rate of rotation. So there are many ways. One, I will try to give you those that you don't really use it often. One is basically you bring the magnet nearer. So when you bring the magnet nearer, then your magnetic field strength will actually increase, right? And therefore the interaction will increase. Number 2 is, of course, you use more turns in the coil. So if you use more turns in the coil, it could be like maybe the first coil is just like 1 loop, then you use more turn, then second loop. Okay. Explanation, basically for both feature, what you are trying to achieve is you want to have a greater interaction between the magnetic fields. Even if you use a larger battery, larger current, lower resistance, all these things, right, in the end what you are trying to do is you are trying to make the magnetic field interact more with each other. Yeah, when you use multi-coil, same thing, right? You use a coil horizontal and then you use a coil in vertical, same thing, right? You just want the interaction to be larger. Okay, so this can be like a general explanation for all motor question. Okay, last but not least, we have the OR question. So first question, what is wavefront? Check textbook. Okay, 12.2, you are given wavefronts. You have 2 buoyant, one after another. Okay, so let's see what are the things that we can sieve out. Just by looking at this figure, I can say that the profile at the side will look like that, right? Yeah, at time equals to 0, which is the picture taken at this time, you can see that buoyant A is actually on the wavefront, meaning that buoyant A is actually on the crest, and then buoyant B is next, in fact is in between 2 crests. So in between 2 crests, this is a crest, this is also a crest. So in between two crests, meaning that this is B. So at the point that this figure 12.2, the picture is taken, it looks like that. Then after that, it says that the wave takes 0.8 seconds to move from A to B. So what does this mean? A wave takes 0.8 seconds to move from A to B. So you can interpret it as the crest. Maybe one crest of the wave takes 0.8 seconds to move from A to B. What does it mean? So here, can you see that I purposely draw, there's a crest on A that is red color. Can see this part? So you can see that B is here, right? B is here, right? This is B, this is A. So this crest takes 0.8 seconds to reach B. What does it mean? 0.8 seconds later, the red crest would have moved to where B was. Yeah, there. So it takes 0.8. Now what does this tells you? This tells you what? You see, in order for the crest at A, the red crest, to move to B line, right? You need to produce this green crest to push the thing over, right? So it means what? It takes 0.8 seconds to make half a wave, right? Correct or not? Because one full wave looks like this, right? So now 0.8 seconds, you are making half a wave. So by doing this, we can already deduce just by this one single sentence, right? You can already deduce, if you understand, that the period is just 0.80 times 2. Okay, if you do not understand this, do get in touch with me. Seek consultation. I have posted the booking of appointment link on WhatsApp. You can book there. Okay. So once you know that, you would be able to find that your period is actually 1.6 seconds. For this particular case only, it's not always you see 0.8 or is another number, you just times 2. It's not always times 2. It's only for this case. Okay. So here you can see why, right? The crest got pushed to B. In order for the crest to be pushed from A to B, the wave must have generated this green color part, and this green color part corresponds to half a wave. So in another word, you use 0.8 seconds to produce half a wave. So therefore, the time taken to produce one full wave is 1.6. Okay, next I'm given 12.3. 12.3 is just a displacement distance graph. What you can find out from there? Well, distance, right? Distance means wavelength lor. So from here, oh, actually I don't need that. You can actually look here. So I can actually find out from here that lambda is 2. Be careful, meter, so no need to change. Okay, can. So I found that out. Okay, let's see what do I need. Okay, period. Part 1, I need to find frequency. To find frequency, I will need the period. So I've already explained to you. Remember 2SF at the end. Determine wavelength and then the speed of the wave. I have already shown you. From 12.3, you can find that lambda is 2 meter. And then from the previous question, you can find frequency. So remember, when you are calculating, use the full answer, the fuller answer, not the rounded up one, only for theory, okay? Then you should be able to get the answer 1.32 SF, okay? In part 3, I'm supposed to draw using arrow direction of the buoyant moving in the next instance. So what is next instance? Next instance means if this picture, this line is taken at time equals to 0, can you predict when time equals to 0.1? So therefore, I have tried to move the wave. So when I move the wave slightly, this blue dotted one represents the time t equals to 0 plus plus lah. So you can see that at this new wave, your buoyant A would have, buoyant A will be always vibrating along this black line, right? So I know that at this point, this is where buoyant A will be at time equals to 0. And this part here will be where buoyant A will be at time equals to 0 plus plus. So meaning that my buoyant A would have to move up, right? Same logic. Now you tell me how buoyant B will move. right? Buoyant B was here when time equals to 0, and buoyant B will move along this axis, the black one that I just draw. So the new position of buoyant B will be here at time equals to 0 plus plus. Therefore, buoyant B will move down, right? Yeah. Actually, PHS is very kind, because even if I don't know this technique, right, I can use common sense. Buoyant A is already at the lowest position, so in the next instance, definitely go up. Buoyant B already at the highest position, so the next instance must always go down. So actually, I don't really need to draw this blue dotted line. But if I were PHS, right, I will set buoyant A here. If I set buoyant A here, right, it can either go up or down. You really need to go and draw the thing. So if this is buoyant choy, the green dot, right, buoyant choy can go along this black line. So you must be able to draw the blue dotted line and determine that, oh, buoyant choy will actually appear here at time equals to 0 plus plus. Then you will know that buoyant choy moved down. If not, you will be stuck. So anyway, that's one thing lah, okay? Okay, part C, they give you another passage. Like I said, I don't have time to read all the passage, so I will just highlight. So I know that, oh, it's ultrasound, this is the frequency, and of course, they are very mean. I don't know why PHS give all this. If I send this paper with all these prefixes, people like N, people like, you know, Kartik, people like Kiraf, the careless ones, Xingyi as well, they will all fall into this trap. They will forget that there's prefixes, and even Megan sometimes, yeah. So there's a prefix, so always pay attention to it. Prefix, check. Okay, then after that I see speed, and okay, so basically this entire passage to me, right, that's why I cannot do biology. This entire passage to me, right, is just these numbers stood out. Okay, then I'm going to skip everything. Okay, other than the time taken to reach the detector, state how the echo, I just need to state how the echo will be different from the pulse send. Oh, I need to explain. So how will sound differently? Well, I can comment on pitch, period, speed, and loudness. Then obviously it will be softer because the amplitude is lower. I need to explain because I got 4 answer line, so I need to extend to have a secondary explanation. So why the amplitude is softer, lower? Oh, it means energy must be lost lah. So because it's traveling through water, it is pushing against the water molecule and all that, right? So definitely when the sound wave is traveling through water, and of course it is getting reflected by the fishes, energy will be lost lah. So another thing is that there's also ocean current, so you can also comment on that. Since we are on the topic of sound, right, I just want to highlight when you have pitch, you know that if pitch is high, then of course frequency will be high, right? In another word, the period will be low, right? And when we talk about sound, right, actually sound, the speed of sound is usually constant. The speed of sound. So the speed of sound depends on the density of the medium, right? On density of medium. So if you shout or if you scream high pitch, low pitch in air, actually the speed of sound is constant, right? Now what it means, so if you have high pitch, you would expect, like for example, it's 300 lah. Let's say that's the speed, right? So V equals to F lambda, right? So high pitch maybe you scream at 300. What would be your lambda? 1, right? So next time if you shout at low pitch, the speed of sound is still 300 because it's still in air. So let's say now your frequency is of course lower. Then what would be your wavelength? Your wavelength would be 30, right? So what does this tell you? This actually tells you what? High pitch, right? Your lambda is low. Low pitch, right? Your lambda is high. So sometimes for some very evil MCQ, they will say high pitch, low pitch, right? Then they'll ask you to compare the wavelength. So high pitch, low pitch, you will have a series of stuff. Frequency is high, period is low, frequency is low, period is high. And you can see that all the wavelength and period will all be different. Okay, just take note because I've seen some O-level question in June that asked something like that. Okay. Part 2, the last part of the question is like the super straightforward one. I think PHS also think that you all are very tired towards the end, give you an easy question. But they still want to maintain their evilness and give you prefixes at the end. So remember, put star. Whenever you see you need put star. So this time taken, right, is for two-way. So what do I mean by two-way? Well, the timer starts when the signal is first generated. Signal travel down to the ocean, hit the fish, come back up. Once the ship detected the returning echo, it stops the time. So actually these 150 milliseconds, right, cover the time taken to travel down and come back up. So if you just want to know this distance, this time here corresponds to 2D. So that's why here you see 2D. So you basically do the math. You can use this formula because like what I said here, speed of sound is constant. So when the speed is constant, you can use your primary school and lower set speed formula.